The maneuver represents a set of instructions for the driver. For example, accelerate up to 50 km per hour, keep this speed for 10 seconds, then release the gas pedal and step into the brake pedal. Follow the road during all these maneuver steps. A maneuver is broken down into maneuver steps. A maneuver step can handle longitudinal and lateral steps combined or separately. These are executed one after another. A maneuver represents the control action that intends to reach a certain vehicle motion. In the example, accelerating to 50 km per hour can be done in the first maneuver step. In this case, the longitudinal description is accelerate forward. The lateral description is set to follow the road. And the end condition is reached if the vehicle speed overcomes 50 km per hour. Let's take a look at a simple braking test run and observe it in Movie NX. In this test run, the vehicle first accelerates to 70 km per hour until it reaches the limit and brakes after the marked line with 60% braking power to a full stop. All of this while driving on the center of the road. On the lower left corner of the main GUI, there's a maneuver short description. Currently maneuver step is 0 accelerating and step 1 braking to standstill. To open the maneuver menu, we can click in this maneuver short description or open the scenario editor and go in a dynamic scenario mode to maneuvers in the Ego Vehicle menu. On the left side of the window, you find a list of maneuver settings. Currently maneuver 0 is selected. You can select different maneuver steps by clicking on them. On the right side of the window, we see the parameters associated with the maneuver step 0. Let's analyze each parameter carefully. Longitudinal dynamics is set to IPG driver, which is a controller that mimics real human driver behavior. The speed target is set to 70 km per hour. This means that the IPG driver will initially accelerate the car as fast as possible until the speed limit is reached and will maintain the speed. This is also dependent on the driver's parameterization. The lateral dynamics is set to IPG driver as well and mimics the real human behavior also. The track offset is 0. That means that the IPG driver will steer the car trying to maintain it in the center of the road. And the end condition has been reached when the vehicle is at a 650 meters front mark. This terminates the core maneuver step, and with that, we will then proceed to the next one. On the next maneuver step, longitudinal dynamics is set to manual, which sets the values of the pedals and gears. The clutch is set to 1, which means it's fully pressed, while the brake is set to 50%, which means press halfway. The end condition is met when the vehicle is less than 0 meters per second fast. Since there are no further maneuver steps defined, the simulation ends automatically. Let's build a complex maneuver from scratch. For this, I prepared a test run called City Driving with no maneuvers. We will first explore the scenario route by let the IPG driver drive through the scenario, and we do this by creating a new maneuver a new maneuver step and setting a long duration as end condition, and we're using here the default IPG driver. On the top left, there's an overlay of the used route. The route is quite simple. You're just driving around the block, passing by a series of parked cars, and last step, crossing an intersection. So, Let us add complexity by adding two distinct events. The first one is to park the car at the parking slots on the left, remain parked for a moment and then get back and continue driving. The second is to create an emergency braking maneuver that is triggered by the detection of the traffic vehicle in such a way that you are able to avoid the collision. We start by determining the end condition of the first maneuver. We can use the route overlay on the top left in Movie Next to determine the appropriate vehicle road position. The UAQ vehicle S road can be searched by right-clicking on the empty field in end condition in our maneuver context. We set the vehicle S road position greater than 389 meters. Then we want to stop the vehicle with the stop vehicle maneuver. We set the stop distance to 20 meters and we set the duration distance also to 20 meters. Now we want to smoothly drive into the parking space. Therefore, we set the IPG driver to 5 km/h and we use a steer step maneuver with an amplitude of 360 degrees over 2 seconds. I have previously determined the distance should be 12 meters as end condition. And we add a description to the maneuver. At least we want to remain stationary for a moment. We use the manual option with the clutch and brake fully pressed. We change the DT of the brake to 2 seconds to allow for a smooth braking. And we set the overall duration of the maneuver coming over to 5 seconds. Let's see how this is looking so far. We can use the hotkeys F4, F3 and F2 to accelerate, resume or pass the simulation. The car has parked as expected. Next, you want to perform the same actions of the last two maneuvers for in reserve. To save time, copy and paste the maneuver 2. We set the longitudinal to driving backwards 5 km/h. We change the description to backing out. Now we will copy and paste maneuver 3. We set the gear to 1 and straighten the wheels. We use the steer step in lateral dynamics with the amplitude 0. Nevertheless, we change the duration of the maneuver to 2 seconds. And one more thing is that we set up a placeholder maneuver just to see the vehicle driving away. Let's observe the progress. Click key F2 and we can pause the test run on the end of our successful parking maneuver. Let's go to the second part of the test run, emergency braking on the intersection. First, we're importing the maneuver from the previous braking test run. For this, we're going in the maneuver menu, then use the import function, search for the braking test run, and now we are loaded the whole maneuver from the test run. Because we're only needing the braking step, we're copying this and importing it to our maneuver 0 with paste. We can delete maneuver 1. For detecting a traffic object, we also activate an object sensor that was previously defined. This is an idle sensor. This means it simulates the peripheral vision of the driver. To achieve that our vehicle brakes to another traffic object, we use the value of the relevant target detection in maneuver step 6 to trigger the braking event. If the value of the relevant target detection is true, then we perform a maneuver step jump to maneuver step 7. We use the term eval to indicate that this is a real-time expression. Let's see if this was enough to avoid a collision. As soon as the traffic car is detected, the ego vehicle begins to brake and the collision is avoided. Success. The maneuver was therefore successful and the collision was prevented. Thanks for watching and we hope you will enjoy the other online tutorials from IPG Automotive.